The final frontier is no longer just about exploration. It's about data. But here's the catch. Our current space infrastructure is woefully unprepared to handle the deluge of information being generated in orbit. As low Earth orbit, LEO, experiences its most rapid expansion ever, the nature of its payloads is shifting dramatically. Gone are the days of simple communication relays. Today, initiatives like StarCloud are deploying and training large language models in space, marking the dawn of the space data center era. Yet, the growth of broadband constellations and on-orbit processing missions is outpacing the evolution of their underlying data handling architectures, leaving a critical gap in data resilience. And this is the part most people miss. Traditional data protection methods like RAID, redundant array of independent disks, simply can't be crammed into a CubeSat. On Earth, RAID ensures data survival by splitting information across multiple drives, allowing recovery if one fails. In space, however, a single satellite's limitations, mass, power, and volume, make internal RAID redundancy impossible. If a satellite carrying processed AI models or critical sensor data is hit by radiation or debris, that data is lost forever. Even advanced constellations like Starlink, which use inter-satellite links for internet services, don't operate as distributed storage clusters. They're still treating satellites as isolated devices, a relic of early small-sat mission design. But what if the constellation itself could become a computer? This is where the concept of a constellation-level RAID, or what I term an orbital redundant array of independent devices, ORAID, comes into play. By striping data fragments and parity bits across multiple neighboring satellites via inter-satellite links, ISL, we can create a self-healing cluster. If one satellite fails, the surrounding nodes mathematically reconstruct the lost data in real time. This distributed architecture relies on a coordinated mix of storage, parity, and coordinator satellites, ensuring data integrity even as individual spacecraft fail or degrade. Disclosure: the author is the inventor of ORAID, a patent-pending architecture, U.S. Provisional Application No. 63/934-397. But here's where it gets controversial. This architectural shift isn't just about LEO, it's a prerequisite for the lunar economy. Establishing data centers on the moon's surface is risky and prohibitively expensive due to the challenges of soft-landing sensitive servers. A more elegant solution? A geostationary moon orbit, GMO, data constellation. By placing data nodes in a stable orbit around the moon, we can create a high-bandwidth orbital cloud that services lunar assets without the risks of landing. This builds on existing research into cislunar dynamics, particularly around Earth-Moon Lagrange Point 1, EML-1, which has long been studied as a stable outpost for spacecraft. A GMO data layer becomes a natural extension of current mission architecture, with surface rovers uploading raw data to the GMO cloud for processing and storage, linked back to Earth via gateway nodes in geostationary orbit, GEO. But who stands to benefit from this? The answer isn't limited to a single entity. Commercial operators planning AI-capable clusters in space, government agencies safeguarding critical records, financial institutions seeking off-planet disaster recovery, and researchers archiving vital medical datasets, all could leverage this fault-tolerant storage layer. But is this the future of data resilience, or a costly over-engineering? As climate-driven disruptions, infrastructure vulnerabilities, and existential risks to terrestrial data centers grow, relocating vital information to orbit emerges as a strategic response. Yet, the question remains, are we ready to abandon the standalone satellite mindset and embrace distributed resilience? The physics of space demands it, and the conversation must start now. Whether an LEO, MEO, GEO, or GMO, failing to modernize redundancy will stifle future missions. What's your take? Is ORAID the future of space data resilience, or is step too far? Share your thoughts in the comments. Let's spark a cosmic debate.